Hi, it's Tim. Welcome back to the corner. I'm going to have a very hard time hiding what's on the bench today. So this is an Amiga 1200 and I'd like to thank John Bickerstaff for this amazing gift. And let's not hang about, let's get into it. Now, I've known John since way back in the old days, probably 81 or 82, when I was a lowly student and I had discovered a Commodore PET, and I found this organisation called ICPUG and I joined it. And John at the time was the discounts officer. Over time, John went on to become chairman and I went on to become the magazine editor. And the rest, as they say, is history. Anyway, let's crack on. Let's open it up. So, what have we got? A2091 installation software, hard disk software, manuals. So, Amiga 2000 series, that's interesting. Keyboard equivalents, that's for professional page, okay. Those are some screws. Workbench 2.04. How to set up the Amiga 2000. GeForce 68030 combo accelerator for the Amiga 2000. Well, this isn't an Amiga 2000, so Amiga 2630 accelerator card user's guide. Again, that's for a 2000. So I suspect this is for hardware that no longer... Mouse mat! New style mouse mat. Right, note to editors. Looks like a press release for the Amiga 2000. Basically a spec. The new Amiga 500. Awesome offer. You can look at these anytime. Retail price list. Live 93, this is interesting. Okay. Amiga 1200 Desktop Dynamite Pack 349.99. CD32 containing diggers and Oscar 299.99. All about the Amiga 1200, Bruce Smith books. I'm sort of hurrying through this because we know what we want to get to. And we can see it in its pink bag. User's Guide A1200 1084S. Okay. Cool. So, the ubiquitous TV aerial cable. Mouse, quick shot, slightly yellowed. Power supply. It's a light one. A600 power supply, it says. Output 5 volts, 3 amps, 12 volts, 500 milliamps, minus 12 volts, 100 milliamps. Very discoloured grommet. Not sure if that's something I need to be worried about. The switch is actually on. Turn that off. Probably need to look inside that. Anyhow. This is the beast. It's nice that the string is not wrapped around it, so we don't have cable burns. Okay, let's get the box out of the way. When I need a PCB, I go to PCB Way. This is a PCB that I got from them recently. It's an EEPROM programmer. It's one of their shared projects. This is another PCB that I will be designing from scratch in next week's video. Now, PCB Way made this for me for just $5. I sent them the Gerber files, and about a week later they sent me back 10 boards. They can do CNC machining and 3D printing and a whole load of other things. So whatever your needs are, you can check them out from PCBWay.com. You could even use this as a drinks coaster. www.pcbway.com. Check them out. And this is the original anti-static bag, I do believe. Okay, so let's take a look. Blanking plate on there. Wonder if that means... Ooh. Not entirely sure what this card is. We've got obviously a RAM card. This is a 68888882. This is an empty socket. And some logic, 40 megahertz crystal. That's got a little sticker on it saying PC1208. Could that be a ROM or something? A little label under there that says tested. Now, I did ask around, and Jan Beta said on his Discord that he thought it could be a math coprocessor card, because they did exist, and maybe this is just an alternate footprint. So this is the through-hole version of the coprocessor, and this is the PLCC version of the coprocessor. Anyway, shall we open it up? I'm sure you're dying to know what's inside it. Today's container for screws is brought to us by the colour green. Right, we've got 1, 2, 3, 4, 5, 6, 7. That is almost certainly going to be the disk drive. We don't want to take that out for the time being. This might also be just the disk drive, I'm not sure, but this question is going to be, does it work? But I don't want to plug it in before I've had a look inside, because we do not know what lies beneath. Okay. So it has a hard disk. We have to get this connector up, so I'm going to try using the chip lever upper. There we go. Keyboard is a bit yellow. Everything is there. Right, so this is the hard drive, Western Digital 540 megabytes with electrical tape on it to avoid contact with the keyboard membrane or the back of the keyboard, although I wonder whether that is actually supposed to be electrically connected. Okay, this just lifts out. It comes off. Green is that way, brown is that way. There's a screw down there. Grab your fingerprints. I want to take this card out. It's going to be difficult. Let's get this off first. Now that's cheating. This tab down here is bent right over, and we can't get this off without taking this out. We can't take this out until we've taken the card off. We can't take the card off until we've got that out. Catch 22. There we go, we can pull it. If in doubt, pull it. So it looks to be in good condition. There is this says tested and the magic number 9335K8. If you happen to know what that is. RAM, obviously. It's on here, Power Computing Limited PC 1208 issue 1. So we'll look that up shortly. So this whole thing now lifts out. Sadly we don't appear to actually have the trapdoor, but we can always 3D print another one. So yes, this tab is the clincher. It's probably the last time this piece of metalwork is going to be on this machine. There we go. Well, it looks pretty clean. This is the old, see if there's any gunk around the capacitors. A little bit of dirt, but not great big gobs of leak, at least. Now I'm not going to just leave it without trying it out. So let's plug it in and give it a go and see if it turns on. Right. 3, 2, 1. It's a good start. Oh. This is workbench 2. That is working. I'm not going to go any further. I'm not going to copy that. Splendid. I'm going to plug the hard drive in and give that a try. Now it worries me that that is just a plain circuit board with, there is a gap, but it's not a very big gap. I might want to put some plastic in there. So this is going to go on here. Just slots in the holes. I'm going to get rid of these horrible, tacky, nasty stuff. Ugh. Yick. Okay, floppy drive. workbench, hard drive, computer screen, power switch. Let's see what happens. I can hear the hard drive rattling. But it doesn't boot. Now, one of the problems for which the Amiga 1200 is notorious is that it has or suffers from leaky caps. Now these look okay. The solder is quite shiny and they don't look like they've leaked. There's no sort of crud on the board or anything, but that's no guarantee that they haven't leaked. These capacitors are notorious. If they haven't leaked, they will leak. And so we're going to replace them. And to that end, I have got a cap kit. And this has come from Amiga kit. Now I bought this off eBay, but they do sell them direct. They're about 10 quid, and to be honest, eBay was a few pennies cheaper. But you know, you buy it how you want to buy it. And they are guaranteed to be a good brand of capacitor. So let's get to work. We're going to have to take the bottom tray off because we're going to need to get underneath for these through-hole capacitors. So my trusty iFixit blankety blank checkbook and pen. Yeah, that's the right one. And we'll just go through and undo these. There we go. Some interesting staining under there. Looks like there may have been some moisture at some point. Okay, underneath the board looks good. So let's see what's in the cap kit. We have got C, D, E, F, G, H. And these are labelled. That's H. That's E. Okay, so I shall make a little map of where each capacitor goes, and then we can get out the soldering iron. I think maybe this needs to come off, because that capacitor there in particular, this one, I don't think is going to be a problem. But this capacitor in here, I'm not going to get into that with this in the way, so this is going to have to come off. Now I've had a look at a number of YouTube videos replacing these capacitors. Most of them have not taken out this connector, but quite a few of them have actually suffered from melted plastic, both on the connector and on here. So I don't really want to melt the plastic. It's going to be easier to take this out, I think, when we're coming to get to this capacitor here. I've scribbled down the positions and values of the capacitors, and of course we've got the leaflet containing the various values that are included in the pack, and we will cross-check those. And once I've taken this out, I'll then take the through-hole capacitors out because they're also accessed from the back. Let's put some flux and some solder on the joints. And that will help clean it off. I've got a fairly small tip on this soldering iron. I think I'm going to do is put some Kapton tape on here just to cover up these surface mount components and then wave the heat gun over it. Kapton tape, of course, is heat resistant tape. That doesn't mean it's heat proof, so we still have to be careful. Now I've got the heat gun set to 320 and about 3/4 of the way around the dial. I'm going to figure a way to heat the connector and pull it out while holding this up. So what have we got? We've got a vise. So if I just rest it in the vise, then there we go, it's out. Now let us take out the through-hole capacitors. Yeah, that's good, there are no broken traces on there. I think that's a big ass ground plane. That's it for those. Let's just clean up the board with some IPA. Okay, now I shall employ the same technique that I have employed before on getting these little beggars out, and that is Kapton snip. It's quick, it's efficient, it doesn't damage the board. So what we do is we cut him in half. We take the bits off, and finally, where did it go? We just clean the legs off. And just clean it up. And I shall do that with all the others and come back when it's done. last one was definitely leaky. You can smell it. So what I'm going to do is put some IPA on these, clean the gunk off. Look at that. That has definitely leaked. It's not as bad as the A600 that I did a little while ago, but you could definitely smell it. That one looks like it's lost its pad. Okay, so this one's definitely lost its pad. We're going to have to find out where it goes to and possibly fit a bodge wire. The others they've cleaned up okay. What you didn't see or couldn't see when I was taking them off was the smell. The damage isn't too bad on the board, but they were definitely leaking. Not badly maybe, but leaking for sure. So they had to be replaced. Looking at the PCB Explorer website, there are only two A2000 boards shown on there, a revision 1D and a revision 2B. Now this board is a revision 1A, and one of those boards does not have this capacitor in this position. The other one does not have this in this position. However, I did look at the schematics, and C407 is a decoupling capacitor in the video circuit. This side goes to VCC and this side goes to video ground. So hopefully if I scrape away a little bit of the track around here, there should be enough copper to actually get a solder connection. Okay, I've turned the board around to make it easier to see, hopefully. But I've scraped away a little bit of the green goo, green stuff. And you can see there is actually a trace. There we go, that links this to this. So we can in fact just join the pad to that area there. So that's what we shall do. Now I'm going to start with this capacitor because this is the trouble one. And what I'm going to do is I'm going to tin this pad, and I've already tinned the trace that I cleaned off here, just so that the copper is covered. Whereas before with the A600, what I did was put some solder paste on these pads. I'm going to try a different technique. I'm going to try tinning it and then just melting the pad. We'll see how it goes. So, blob of solder on that. It's a very tiny pad. I might have to put a wire in and connect that. We shall see. Now these are capacitor D. D. So it's going to go on. It's going to go flying. That would be the smaller pad as well, wouldn't it? What I think I'm going to do, so what I've done is I've tacked a piece of wire onto the negative terminal. It's the negative terminal, you see the little bar of this capacitor, and then hopefully we can actually connect it like that. So I'm going to turn the board around because I'm right-handed, and otherwise I can't do the work even though you can see what I'm doing, if that makes sense, which it doesn't. But right, so the procedure for this is going to be in my pliers. This has been tinned. So what I've done is I've put this on here, and I've just heated that pad. There we go. And then the other side is going to be the wire. There we go, like that. So it's not particularly elegant, but it's on. And now we can go and do the ordinary ones. Once again, tin the pads. Okay, so the surface mount capacitors are all in, or on rather. So let's put in the through hole capacitors. So we'll start with the 2470s. So that's this one here. One, the other one is over here. Okay, and then finally the 2000 microfarads. Okay, that's done, so we need to put this back in. Now it can only go one way round because there are fewer holes this side than there are that side. So we can take that off. Okay, there we are. So now it's plugged back in, ready to try it out again. Let us switch it on. There's no floppy drive, there's no hard drive, so this will take a few moments just to sit and boot up, hopefully. Dum-de-dum-de-dum. Oh, yep, there we go. So that's good. Everything is functional. We can start putting it back together. So I've more or less got it back together. Now I wanted to try it with this mouse because I haven't actually tried the mouse. It's a dual Amiga and Atari ST mouse. It's definitely switched to Amiga, but as you see when I wiggle it about, it does nothing. So let's take it apart. Wiggling the rollers about doesn't seem to do anything, so maybe the mouse is dead, or maybe the port is dead. Okay, this is a tank mouse that I know definitely works. Now we've got horizontal movement, but we've got no vertical movement. And, well, at least the right mouse button works. Can't really select anything. So, let's have a look. Now, I've been looking at the schematics, so I do know roughly what's going where. Move the keyboard and the disk drive out of the way. Now, this is the mouse port. Most of the signals from it are underneath, but I'll show you the schematic on the screen. And what happens is that the signals come through and they are repeated on this header here. So pin 1, pin 1, pin 2, pin 2. Now the mouse X and Y are pins 1 and 2. So pin 1 is the Y, which is not doing anything, and pin 2 is the X, which seems to work fine. And then they go through a low pass filter and some pull-up resistors to this shift register here, U34, which is a 74LS166. So I can look at these signals on the scope and we can deduce what we can deduce. Okay, I've hastily reconfigured this as scope cam, so let's take a look. This is pin 2. This is the horizontal line, and you can see it generates pulses as I move the mouse about. And these pulses are approximately 5 volts. Now this is pin 1, and pin 1 is the horizontal, sorry, the vertical. And you can see it still generates pulses, but they're only about, what, 3/4 of a volt? So that is obviously not enough to trigger it. So, looking at the schematic, this is pin 1, which goes through this little low pass filter, 6800 puff and 68 ohms. And here pull up through 4.7K into the shift register. So I think my first suspicion is going to be, because it's pulled down to earth, it's going to be this capacitor. Now that is definitely going to be on the back of the board. And that means we've got to take all this apart again after we've just put it all back together. So, jump cut. Right, here we are on the back of the board. Now you can see this is the mouse connector, and it's connected down through to that header, and then it goes through this network of resistors and capacitors, which are basically low pass filters. So with it in circuit, we'll just have a little poke around. These 370 should be 4.7K. And they seem to be. Now, this filter, the resistance here is 66 ohms and the capacitance is 6800 picofarads. So we're looking at E355 and E356. Now 356 is this one here, so this is 356. 66 ohms. 355. 67 ohms. Good enough. Let's just look at the resistance across these capacitors down to earth. So 356. This is the one that works. About 5k. And 355, this is the one that doesn't. Ah, now that's interesting. 170 ohms. 160. That does not seem right. I think there's something screwy with that. So, I don't think it would hurt if I just took it off. And it's a low pass filter, it will basically make that noisier. But if I take it off, that might well prove whether that capacitor is faulty or not. Let's do that. A bit like a surgeon, I've got this taped up. So hopefully what I can do is just put some flux on here. There we go. So let's just check the resistance across. It's about the same. So let's just clean this pad up. So in a very loose way, it's back together again, and we can try it out. It's plugged in, mouse is plugged in. I've rested the keyboard on a notepad just so that it doesn't short anything out, and the floppy drive is again resting on a plastic bag so it doesn't short anything out. And let's try it and see what happens. That's a good sign, the floppy's booting. Well, we don't need to wait, we can just... Oh, look at that! Look at that, the mouse is moving around, we have the vertical and we have the horizontal. Left button works. Right button works. This is just a straight workbench disc, there's nothing interesting on it. But that has proved that we now have a working machine. So I need to source a replacement for that capacitor. I've put it into this little pot. Don't know if you can actually see it in there. It's in two parts for some reason. Tiny, but that is now working. Awesome. The other mouse I think needs to be serviced, repaired, looked at. We can do that in another video. So here we have the Amiga 1200. all back up and running. The mouse is working, the workbench screen is working, but it's not over yet. We still have this floating point card to investigate, and it's a power computing card. We know that much. It's a PC1208 68882, 40 megahertz with a 40 megahertz crystal, battery backed up clock. We might want to change the battery out. It's a Panasonic CR2032. Regular coin cell, it has not leaked at all. And 4 megabytes of fast RAM. So we need to investigate that. There's the hard drive inside that we still need to investigate, try and format it and all that sort of good stuff. And we still have this mouse that does not seem to work at all. So please subscribe to the channel to see the videos that we make on that, and like and click the bell to get notified, and we will see you next time. Meanwhile, have a look at that and enjoy yourself. See ya. Bye.